I'm going to explain Gödel's theorem in layman's terms.
Yeah.
Okay. So here's my high school geometry book. Okay. And it's got all of these rules and things in it. Let's say I draw a circle around this geometry book. This geometry book relies on something outside of the circle that you cannot prove, but you have to assume. And Gödel proved that every system is like this.
Every system you can draw a circle around.
Yes.
Depends on something outside of the circle.
Which you have to assume,
Yeah.
but which you cannot prove.
Okay.
Okay? So what that means is there's always more things that are true than you can prove. And it means that any system of logic or any system of belief, any system of reasoning requires faith.
Mm-hmm. Something's unproven.
Faith in something unproven.
Yeah.
And the way he did this was he took the liar's paradox, which is I am lying, and he turned it into a mathematical formula, and he said, can I use this mathematical formula to prove whether I'm lying or not? Okay? And what Gödel proved was only a person independent of the liar can judge whether he's lying or not. He cannot tell within him, he cannot prove within himself that he's telling the truth. Okay? And this was a devastating blow to a whole bunch of mathematicians. Some of them died still in denial, like this has to somehow be wrong. But it was absolutely brilliant. And so he proved that there's always things there's more things that are true than what you can improve, and that whatever, any way that you draw this, even if we draw a bigger circle to now encompass this, we will still then refer to something else outside of that circle.
In this example, that means if we were able to prove the 5 postulates, in the process of doing so, Gödel would say there'll be something still.
Yes.
In our proofs that forces us to make assumptions.
Yes.
Okay.
And I think this is one of the most important things that anybody's come up with, like literally in the last 2,000 years.
And again, this is no longer open for debate. This is solid math.
No, it was case closed in 1931 when Gödel wrote his paper, because his logic is absolutely flawless.
Yeah.
Okay? And it's like, whoa.
Major implications for that.
Major implications.
Right.
It has implications for mathematics, it has implications for philosophy, and it has implications for science, and frankly it has implications for religion. Okay, because so let's do a little experiment here. Okay? Let's say that instead of talking about a geometry book, we're talking about the universe. The universe is contingent on something outside the circle, which you have to assume, but you cannot prove. Okay? There is something outside the universe. And we can define universe as everything physical, everything that you can see, taste, feel, or touch, everything with mass or energy. You can put all that in the circle. There has to be something outside the circle.
Now, would that be debated in scientific circles at that point?
I don't think it's possible. Well, people could disagree with it, but Gödel's theorem applies to everything.
Right. It does. So there's different ideas being thrown. The multiverse.
Right. Okay. Multiverse. Okay. So there's a whole bunch of universes.
Right.
But you still draw a circle around them.
That's the point. Right?
And there still has to be something outside the circle.
Right.
Now, we can go further. We can infer what is outside the circle.
By looking at inside?
Yes. Okay. Because everything if inside the circle we have matter, energy, space, and time, that means whatever is outside the circle is not matter, energy, space, and time. It's immaterial, it's not energy, it's not space, and it's outside of time. Okay?
If those things are completely encompassed, that is, inside. I mean, you could envision in our physical world encompassing these things in a circle, but they're assuming matter, energy, space, and time outside of the circle. But if all of matter,
right,
you're saying, I think that's what you're trying to say.
Yeah.
All of energy, all of space, and all of time is encompassed in the universe, which is the definition of the universe. Right. Then this must not be matter, energy, space, or time.
And even in a thought experiment, is stating the universe, we can define the circle as all universes.
Right.
Okay? That there is something outside the circle is not matter, not energy, not space, not time. Right. Also, systems. Okay? Gödla says everything that is a system requires something outside the circle. Mm-hmm. So this also means what's out here is not. It's not a system. What's a system? It's moving parts. What's out there does not have moving parts. It's not a system. It's not matter. It's not energy. It's not space. It's not time. Mm-hmm. And it's indivisible because it doesn't have parts. And it's infinite because it's boundless. Mm-hmm.
Because that concept of finiteness is within the universe concept.
Okay, mm-hmm. It's infinite. Mm-hmm. Wow.
That sounds familiar.
You take Gödel's theorem and you do some simple induction on it, and you end up with, wow, big surprise, something that sounds an awful lot like God.
Yeah.